potentiometry and voltammetry. In potentiometry, the potential difference between two electrodes is measured with an analyte forming electrochemical cell, while in voltammetry, current is measured at an applied voltage with analyte forming an electrolytic cell. Both the technique involves electron transfer redox reactions occurs on their respective electrodes. The difference between electrochemical and electrolytic cell. Electrochemical cell, also called galvanic cell, involves the conversion of chemical energy into electrical energy due to occurrence of spontaneous reactions occurring at the two respective electrodes. While in electrolytic cell, electric energy is stored in the form of chemical energy due to non-spontaneous reactions which requires external voltage source. Thus, polarography is a voltammetric technique in which current is measured at an applied voltage with analyte forming an electrolytic cell. The analyte is electrolyzed between two electrodes, one of which is small and polarizable electrode, while other is large and non-polarizable electrode. For the analysis, the current voltage curve is plotted, which is called as polarogram. The electrode which does not have its own potential and can take up any potential applied to it is called polarizable electrode. The dropping mercury electrode, abbreviated as DME, is used as polarizable electrode in polarography. The electrode which have its own potential and hence cannot take any potential applied to it is called non-polarizable electrode. Saturated calomel electrode, abbreviated as SCE, is used as non-polarizable electrode in polarography. Let's see the principle of the technique. Thus, polarography involves a study of electrode processes by means of electrolysis of the sample solution. At the electrode, the one is DME, while other is saturated calomel electrode. The electrolysis of the dilute metal ion solution is carried out in the presence of large concentration of electrolyte, which is called as supporting electrolyte, and this electrolysis is carried out under unstirred condition. For the analysis, the plot of current I versus applied potential is plotted, which is referred as polarogram, and it is used for qualitative as well as quantitative analysis of the sample solution. Different types of polarographic cells are used for the analysis. In the diagram, we see the S-shaped polarographic cell consisting of two arms which are joined by using a horizontal glass tube. The sintered glass tube is fitted at the middle of this horizontal glass tube, which allows the electrical connections between these two arms. In one of the arms, the saturated calomel electrode is fitted, while the capillary of the dropping mercury electrode is fitted in another arm. It has a side tube attached to at its base to pass the nitrogen gas through the experimental solution. In actual analysis, the solution arm is rinsed number of times with the sample solution, and the sample solution is filled up to the level of this horizontal glass tube. The rest of the space in the polarographic cell is filled with the supporting electrolyte, and the supporting electrolyte used in polarography is generally the salts of alkali metals like KCl. When the solution arm is filled with the sample solution and supporting electrolyte, the nitrogen gas is passed through the experimental solution to remove the dissolved oxygen to remove its interference. The potential is applied across the two electrodes and the current voltage data is measured in order to get the polarogram for the analysis of the sample solution. Let's see the dropping mercury electrode used as an indicator electrode in polarographic analysis. It consisting of three parts: capillary, mercury reservoir, and rubber tubing. The capillary through which mercury flows must have uniform bore size. The mercury reservoir, which holds the mercury, also contains a sealed platinum wire through which the dropping mercury electrode is connected to the external circuit. The rubber tubing through which the mercury flows is flexible in nature, connects mercury reservoir to the capillary, with the help of which the height of the mercury reservoir is adjusted to change the drop time. During the working of polarographic analysis, the height of reservoir is so adjusted that the drop time is in between 3 to 6 seconds. Once the drop time is adjusted, it keeps constant throughout the experiment. In order to see how the polarogram is used to carry out analysis by using polarography, consider the electrolysis of cadmium chloride in the presence of supporting electrolyte like KCl with the help of polarography. When external EMF is applied, the positively charged ion, that is cadmium ions, in the solutions will get attracted towards the cathode, that is dropping mercury electrode, by an electric force and reduce at the dropping mercury electrode. The current is generated and it is recorded with the applications of applied voltage and polarogram is obtained. The polarogram consisting of S-shaped curve having three parts: curve AB, curve BC, curve CD. With the application of applied potential, initially there is a slight increase in current from point A to point B. The current corresponding to curve AB is called as residual current and it is carried by the ions of supporting electrolyte and residual impurities present in the solution. Beyond point B or at point B, the applied potential becomes equal to the decomposition potential of cadmium ions. The decomposition potential of potassium ions of the supporting electrolyte are much higher than that of cadmium ions. Therefore, though they are having excess concentrations, they are not reduced at this point. Beyond point B, the current is increased up to point C as cadmium ions are reduced at the dropping mercury electrode. Beyond point C, current no longer increases up to point D. It reaches a steady limiting value. Therefore, the current corresponding to curve CD is called as limiting current. The difference between limiting current and residual current is called as diffusion current. The diffusion current forms the quantitative basis of polarographic analysis, and therefore, for quantitative analysis, diffusion current is measured for the analysis of the sample solution. For qualitative analysis, the half-wave potential of the test solution is measured. Let's see what is meant by half-wave potential. It is defined as the potential at which current flowing through the polarographic cell is exactly half of the diffusion current. It is used to identify the nature of electroactive species present in the solution. Thus, half-wave potential forms the qualitative basis of polarographic analysis. Let's see some of the interference in the polarographic analysis. The first one is polarographic maxima. In polarography, sometimes a peak is obtained in the rising portion of polarographic wave. That peak is called as polarographic maxima and it will give the error in the measurement of diffusion current. Therefore, it has to be eliminated. In order to eliminate polarographic maxima, surface active agents like gelatin, dye like methyl red and Triton X100 is used to suppress this maxima. Another interference which occurs in the polarographic analysis is oxygen interference. Oxygen dissolved in electrolytic solution can easily get reduced at the dropping mercury electrode and it gives rise to two polarographic waves of approximately equal heights. Out of the two waves, first wave is obtained due to the reduction of dissolved oxygen into hydrogen peroxide, whereas second wave is obtained due to reduction of oxygen into water. Though this is one of the methods for the estimation of dissolved oxygen, it interferes in the main study as many other species, almost all known metal ions also reduce in the same region. Therefore, the interference due to oxygen has to be removed. In order to remove the dissolved oxygen from the experimental solution, the nitrogen gas is bubbled through the experimental solution to remove the dissolved oxygen. Let's see the application of polarographic analysis. Polarography can be applied for the both type of analysis, quantitative as well as qualitative analysis. For the quantitative analysis, the concentration of electroactive species in the solution is determined by using Ilkovic equation. The equation is ID is equal to 607 NC d raised to half m raised to 2 by 3 t raised to 1 by 6, where ID is the diffusion current in microampere, N is number of electrons involved in the reduction process, C is concentration of electroactive species in millimole per dm cube, D is the diffusion coefficient in centimeter square per second, M is flow rate of mercury drop in milligram per second, T is drop time in second. If we see the terms N, D, M and T are the capillary characteristics and characteristics of the sample solution. Therefore, they are constant and hence diffusion current is directly proportional to the concentration of electroactive species. Hence, concentration of electroactive species and thus the diffusion current forms the basis of quantitative analysis in polarographic analysis. Let's see the qualitative applications of polarographic analysis. In order to determine the nature of electroactive species in the sample solution, half-wave potential is measured. The polarography is applicable to both organic as well as inorganic compounds. Almost all metal ions are reduced at the dropping mercury electrode, as most of the metal ions forms amalgam with the mercury. A series of reducible substances from their mixture can be estimated in one solution, provided their half-wave potential differ by at least 0.2 volt. The organic compounds containing electronegative functional groups like carbonyl, nitro, nitroso, azo and halides have also estimated by using polarography. The polarography is used to estimate dissolved oxygen, and this type of determination has been used in biochemistry for the study of respiration of green algae and study of photosynthesis. It can be used in the analysis of alloys. The polarographic technique is also useful to determine vitamins, hormones. Analysis of drugs and pharmaceutical preparation is also carried out. The determination of pesticides or herbicides residue in the foods, essential oil in plants, determination of purity of honey and sugars is also carried out by using polarography. The polarography is also used in volumetric analysis, and the titration using dropping mercury electrode are called amperometric titrations. In summary, polarography is a voltammetric technique in which current is measured at an applied voltage with analyte forming electrolytic cell. In polarographic analysis, the dropping mercury electrode is used as an indicator electrode on which reduction occurs, acting as an cathode, while saturated calomel electrode is used as a reference electrode, which is acting as an anode. The test solution is electrolyzed in between these two electrodes, and the current voltage curve, also called polarogram, is recorded. In the test solution, a small amount of surface active agents like Triton X100, gelatin and dye like methyl red are added to eliminate polarographic maxima, while in order to remove oxygen interference, nitrogen gas is bubbled through the experimental solution. The polarogram is used for the qualitative and quantitative analysis of organic as well as inorganic compounds. Diffusion current forms the quantitative basis of polarographic analysis, while half-wave potential forms the qualitative aspects of polarographic analysis. So thank you.